Alright guys, welcome back. We're going to be solving another question from the second chapter of Engineering Mechanics by Meriam, and then this one we need to compute the magnitude of the moment MO of the 250 pounds force about the axis OO. So we have this axis OO that we need to figure out the moment of this force. The first step in here is that we're gonna resolve this force into three different components that we have. It's going to have one component in this direction. Since we are in 3D, this is going to be the three components of this force if we resolve it in each of the axes that we have. So I'm not going to name the axis because we don't need to. We know this angle right here is 60 degrees, so this angle would be 30 degrees. So this component in here would be 250 cosine of 30 degrees. And if we want to resolve that to the other two, we know this will be, which is going to be the component of this force in this plane that we have in here. The other would also the red force, which is the projection of the 250 in the plane underneath. So it's going to be 250 sine of 30. And if that's the case, the other force in here, which we know also this angle is 40 degrees, so this will be 250 sine of 30 cosine of 40 degrees, and the other one would be 250 sine of 30 degrees sine of 40 degrees. So basically this is the other force, and we have this right triangle in here. The hypotenuse is this part, so we can find all these forces in here. So the way we're going to look at this, so basically if we look at from the point of view of this guy, we have the moment of these forces that we have on the right hand side. If we look at this force, we can see that this is going to make a moment in this direction about the axis OO, which is going to be a counterclockwise moment. So the first moment that we have, we're going to consider counterclockwise moment positive 250 cosine of 30. That's our force, and the distance would be basically the vertical distance to the axis. So it's basically this distance, which is 12 inches. So one of the moments are out. Now we have to look for the other moments that we have for this question. So let's see what we have for this force in here. 250 sine of 30 sine of 40. And again, if we look at it, this force, if I just continue the line of action, the force is going to be like underneath the axis OO. And if we look at it, this one also is going to make a counterclockwise moment from the point of view of this other guy again. So plus 250 sine of 30 degrees sine of 40 degrees. That's our force. And for finding the moment, we need to also figure out the distance. And the distance that we have in here is this distance in here. Let me try a different color. So this distance. And we know from here to here we have 8 inches. And this distance in here is the distance that we have in here. So 4.2 inches. So here, which is the distance that we are interested, we're going to have 8 minus 4.2. So that's the moment of the second force. And the last force is the one in here. And if you look at it, it's parallel to the axis OO. So since it's a parallel force to the axis, it's not going to make any moment, and we won't have any moment for that one. So all we need to do in here is just to calculate this value in here, and it's going to give us the moment. So 250 times cosine of 30 times 12 plus 250 sine of 30 sine of 40 times 8 minus 4.4, and yeah, that's gonna give us 2903.4 pound. And all the distances, since we have a double prime, they're all in inches. And that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.